Today we will be looking at Surprisal values for Bessey sequences. So if you haven't looked at my videos regarding Bessey sequences, you may want to take a look at those before watching this current video. So we will be looking at Bessey sequences of order 8, Quasi-Bessey sequences of order 16, and Bessey sequences of order 32. Now recall that the quintessential structure for a Bessey sequence is the following: 1 0 0 1 0 1 1 0, where the zeros and ones are simply denoting dichotomous characteristics, or we view those cards as having dichotomous characteristics. So what does a Bessey sequence of order 8 performance look like? Well, there are many performances that can be designed taking advantage of the wonderful properties of Bessey sequences. So I've listed just one here. So what does it look like? 8 random cards are chosen. After thorough mixing of the 8 cards, they are divided into 2 piles of 4 cards that match a written prediction. Okay, so let me just show you kind of what it would look like. So the idea is that you would start with 8 random cards in this particular rendition of a performance using Bessey sequences. And the spectator is free to mix the cards as much as they like. These are truly 8 random cards. So you just put out 8 random cards. Maybe we'll take some from different places. Okay, there we go. We have 8 cards. Okay, and then what a person would do is we would just take a look at these 8 cards, kind of lay them out like so. And then you as the performer would simply write down the identities of the cards that were freely chosen by the spectator. Now, secretly, what you're going to do is on one line of your piece of paper, or for one grouping of the cards, you're going to write down the card that's in the first position, the 4th position, which is the 10 of spades, the 6th position, 10 of hearts, the 7th position, Queen of diamonds. That will constitute one group, and the remaining 4 cards will constitute the other group. So essentially, you're just taking advantage of the structure right here, okay? And then you simply just close up these cards, and then with the Bessey sequence of order 8, if you've watched any of the videos, we can mix this packet virtually forever and not lose information as to where those 2 groupings of cards are relative to each other. Okay, that's the amazing thing. And then at the very end, after all of that mixing, where key choices are being made by the spectator, that's important. The spectator is really dictating how things are done. These 8 cards are divided into 2 piles of 4 cards. Okay, so they're divided into 2 piles of 4 cards. And the dealing out into the 2 piles, if done correctly, will still look like a random dealing out of the cards into 2 piles of 4 from the perspective of the spectator. But nonetheless, when these cards are revealed within each pile of 4, when you reveal what those are, it will perfectly match the groupings that you've made note of on your piece of paper. And that's after tremendous mixing and, quote, randomization of the cards has occurred. So the question is, what is the surprisal associated with this particular routine? In fact, it will be the same surprisal value for any routine taking advantage of the Bessey sequence structure for a packet of 8 cards. Okay, so that's what we're looking at today. So what I've done here on the right is I've created a Desmos activity that will help us calculate the surprisal values for Bessey sequences and quasi-Bessey sequences. So let's go ahead and take a look at this situation. You correctly predict a group of cards in no specific order that are randomly chosen from what the spectator believes is a completely shuffled, that is, mixed packet of cards. Probability analysis. We will assume that each card is equally likely to be selected for any one group. The spectator assumes that a group of R cards, so in our particular case, it will be 4 cards, are randomly chosen from a randomized packet of 8 cards. So N for us right now is 8. The number of ways of choosing R cards, that is 4 cards, from a packet of N cards, that is 8 cards, is found by performing the following calculation. N factorial divided by R factorial times N minus R factorial. Okay, so you'll probably recognize this as the formula that gives you the number of combinations of N objects taken R at a time. Now, of course, only one of these groups consists of exactly the R predicted cards. Therefore, the probability of drawing the R predicted cards in no specific order from a randomized packet of N cards is going to be 1 divided by the above quantity, which will simply flip the fraction. So if you notice here, I have a slider which will allow us to adjust this activity to the various Bessey sequences. Now at the moment, I have it set for the Quasi-Bessey sequence of order 16. So we'll go ahead and adjust that down for our current activity. So there we go. We have 8 cards. Now we are selecting 4 of them. So the number of ways that you can select 4 cards from a set of 8 cards is 70. So that means in particular, if we correctly guess the composition of one of 2 of these piles of 4 cards each, there is a 1 divided by 70 probability that we would be successful in our guess or prediction. So very small. Now let's go ahead and convert that to a surprisal value, where we will be able to interpret it in terms of ordinary coin tosses. Okay, so let's move down here. So recall, the surprisal value for a random event is equal to log base 2 of 1 over the probability that that random event occurs. So here, what I've done is I've replaced R with the variable X so that we can graph it and also create a table of surprisal values. So to be clear, N right now is set equal to 8 and R is set equal to 4. So with those 2 values, we find that the surprisal value for a Bessey sequence performance of order 8 is 6.13 bits. Once again, what does that mean? Well, we'll go ahead and round it down. That's reasonable to do, so 6 bits. So what it means is all of the performances that I have shown on my channel that deal with Bessey sequences of order 8, each of those have a surprisal value of 6 bits. Once again, what does that mean? That means the level of surprise associated with those performances in the minds of the spectator is the same level of surprise they would experience in witnessing someone tossing 6 fair coins high up into the air and having that person call out heads for all of them, and then watch those crazy coins hit the table and bounce and eventually settle down, and all 6 coins are face up. The level of surprise associated with that random event is the same, in fact slightly less, than that of any of the Bessey sequences of order 8 routines. And then what we've done below here is I've gone ahead and graphed it for various values. And remember, X represents how many cards or the size of the group that we're selecting. So we, right now, are focused on selecting 4 cards out of the 8-card packet. And so there we go. There's our Surprisal value that we saw earlier. And as you might imagine, that is also the maximum Surprisal value for selecting a group of cards from a packet of 8 cards. Any smaller or larger selection of cards will lead to a lower Surprisal value than we achieved in all of our performances with Bessey sequences of order 8. Okay, so moving ahead to Quasi-Bessey sequences of order 16, we find the following. Recall a Quasi-Bessey sequence of order 16 has this form right here. So what does this one look like? Well, if you've watched my video on Quasi-Bessey sequences that uses the law of attraction narrative, and that particular performance gets a wonderfully strong response from the spectators that I've shown it to. And we'll see why in just a moment, because the Surprisal value for that routine is very high. So what they're witnessing there is extremely unlikely, given the assumptions that they have in their minds about what they're seeing. Okay, so what does it look like? Well, here it's 16 random cards are chosen and noted. After thorough mixing of the 16 cards, they are divided into 2 piles of 8 cards that match a written prediction. So in this particular case, you would just deal out 16 random cards. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's fine. And then you can have the spectator mix these to their heart's content. Okay? So these will truly be random cards, and they can be chosen by the spectator. In fact, ideally, that should happen. Okay? And so in what I'm describing here, what a person would do is just kind of show those cards to the spectator, and it will help convince them that they've chosen a nice random selection of cards, colors and suits and values. And then you just tell the spectator, okay, I'm going to just quickly write down which cards you selected. So for example, for 7 of hearts, you can just write 7H. Now secretly, what you're writing down in one group of 8 cards, and the other group of 8 cards will make up the remaining cards, is you're following the Quasi-Bessey sequence structure right here. So the 1s will be put into the same group, and the 0s, the remaining cards, will constitute the second group. Okay, so in particular, what this means is the 1, okay, that would correspond to the card in the first position here. So on our piece of paper, we would write down 7 of hearts, and then we'd come over here to 5 of spades, and then we'd come over here, King of diamonds, Jack of diamonds, and then we'd skip those 2 and then come over here, 8 of hearts, Queen of diamonds, skip 1, come over here, 9 of spades, and then Queen of hearts. So that will constitute one of the 2 groups at the very end, guaranteed. Okay? And then the other cards will make up the remaining pile of 8. Okay? And now these cards are then thoroughly mixed using all of the many shuffles that preserve Quasi-Bessey sequences of order 16. Okay? And there's many, many of them. Okay? So after tremendous mixing in which the spectator is dictating just about everything, you come back and then you deal these out kind of randomly into 2 piles. Well, secretly what you're doing is you're just rebuilding this again. So you're doing, like, you can put the 1s here and then the 0s here if you like. So you can go 1 0 0 1 0 1 1 0. 0, 1, 1, 0, 1, 0, 0, 1. Now, if you do that, that will look extremely random to any observer. But what you've done is you've pulled that sequence apart again, because this structure was preserved by those many, many, many shuffles that you put it through, okay? Now, from the point of view of the spectator, what kind of level of surprise would they experience in watching you do all of this, and then you show the identity of, of the piles here, and they match what's written for your prediction on your piece of paper? What degree of surprise would the spectator experience in witnessing that? And what would be the equivalent way to view that surprise in terms of ordinary coin tosses? Well, that's where our Desmos activity comes in. So let's go back up here again. We just have to adjust our sliders. Okay, so all of the same information applies. Okay, the only difference now is that we're looking at a total packet size of 16, and we're looking at two groups of 8. Okay, so here we'll slide it over to 16. And then we're looking at selecting 8 at a time. That's what we've done. So if we come down here, we can see the following. In fact, perhaps we should move up to the number of possible outcomes and the probability itself. So let's back up for a second. So how many ways can that be done? Given 16 objects, how many ways can you choose 8 of them, where you're not worried about the order in which those 8 objects are chosen? Well, here it is. So it's 12,870. Well, to get the probability that you would just randomly guess the exact grouping at the very end, the groupings here, that would be 1 divided by that number. So very, very small. Now that number is so small that how would you even interpret that? Well, that's where Surprisal theory comes in and gives us a very concrete way of interpreting rare events. Okay, so let's come back down here. Okay, so what we're looking at is the level of surprise associated with witnessing this performance being done successfully is 13.65 bits. Okay, so what's our interpretation? Well, I suppose we could round this up to 14 bits. That would be reasonable. So the interpretation here would be that the Surprisal level or degree of surprise in witnessing the successful completion of this routine, where you're able to predict ahead of time the exact cards that make up these two piles after all of the, quote, randomization, it's the same level of surprise one would experience in witnessing 14 fair coins being tossed high into the air, and while in the air, that person calls for heads on all of them. They're all going to land heads up. And then the two of you watch the coins land and bounce and settle down, and eventually every one of the 14 coins is heads up. The degree of surprise associated with witnessing that random event is the same or very similar to the degree of surprise one would experience in watching a successful completion of this performance here. Okay, so that's very, very unlikely. And then, of course, down below, once again, we have a table of values. We have a graph of the Surprisal function. There we go. And we can also, I guess we need to click Show All. The particular one that we are working with, because we're breaking the packet of 16 cards into two piles of 8 cards, is here is our Surprisal value. And as you can see, that's where the maximum occurs. So we hit maximal Surprisal for what can be done with this packet of 16 cards when randomly choosing a certain number of them, but being able to predict what those cards are in the end. Okay, so there is our Surprisal value. Okay, so for our final little example of Surprisal values today, we're going to look at Bessey sequences of order 32. And I do have a video or two dealing with Bessey sequences of order 32 and actual performances as well. Okay, well, a Bessey sequence of order 32 is a long sequence. So something like this may be best to set up ahead of time. What it would look like if you actually followed my recommendation here, it's not completely unmanageable. You could do it. Because the spectator will just think you're writing down the identities of the cards. They won't know that you're grouping them in a special way. So we just need 32 random cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2. Okay, I believe that's 32 cards. Okay, so it's getting to be kind of big here, okay? So I do encourage you to watch my performance dealing with Bessey sequences of 32. It's probably a more manageable routine than what I'm suggesting right here, but that routine and this one have the same surprisal value. What I'm going to try to do here is fan these out so that we can see all of the cards. Okay, can we see them all? Barely, maybe. Okay. Wow. Yep. They're kind of hard to display in this tiny little space here. I think you can technically see all of them now. Okay. So with our Bessey structure of order 32 up above, a person would, and we can just start here. We have a 1, 0, 0, 1. So this is viewed as a 1. So this would go into like a one grouping. And that grouping would consist of this card, okay, and now you skip over here, skip those two, and then pick up the Jack of Spades, skip this one, and then pick up the next two consecutive, skip the next two, and pick up the next, and so forth, okay? So that will give you your special grouping at the end. Okay. Now, I think what I may have done in the presentation, the routine already created for Bessey sequences of order 32, is I had it pre-set up with special cards in these positions from the start. And so that way, and you can display it for the spectator, they won't see anything. They'd have to stare at it for quite a while to actually detect any kind of real structure in it. Because look at these zeros and ones. I mean, it'll take you a minute to go and see, is there any kind of structure there? There is, but it probably won't be perceived very quickly, okay? And so with these 32 cards, you can now put it through tremendous, quote, randomization dictated by the spectator. And then when you're done, you can divide these cards into two groups of 16 cards each. Okay, so I'll just kind of pretend I've done that. So here's 16 of those, and here's the other 16. So we divided the packet, okay? And then you bring out your, quote, written prediction and show that the identities of the cards in each pile match the two groupings that you've listed on your piece of paper. Absolutely amazing. Okay, so what is the surprisal value for this particular routine? Well, let's come back to our Desmos activity here. Okay, so what we'll do is we'll use the sliders and we'll move the first slider over to 32. And then we're selecting, quote, 16 cards at a time because we divided the 32 cards into half, 16 cards in each. So how many combinations are there of 32 objects taken 16 at a time? Well, it's 601,080,390. Well, the probability that we would just randomly guess on our piece of paper the final groupings here would be 1 divided by that, because there's only one particular grouping that will agree with the one we have here. And here's the probability, and once again, it's so small that it's hard to interpret that. So what we do is we calculate the surprisal value for that probability or random event. And what we find is the surprisal value associated with this performance is 29.16 bits. Okay, so once again, the interpretation will be the same. The level of surprise in witnessing a successful completion of this performance is the same level of surprise one would experience in witnessing 29 fair coins being tossed high into the air and then having that person predict that all 29 coins will land heads up. And they do. Each and every one of those 29 coins lands heads up. So that's the level of surprise one would experience in witnessing this performance here, or other ones that I've shown on my channel dealing with Bessey sequences of order 32. And as before, we have the Surprisal graph. Here it is. It hits a maximum, of course, at 16. So we can see it right. Let me expand this here. Come over here. So right at 16, which is what we're looking at, 2 piles of 16. That's the maximum Surprisal value possible when selecting a group of cards from this set of 32 cards. Okay, so that gives you a feel for the Surprisal value of really all of the Bessey sequence performances that are done on the Hidden Structures channel. Okay, and so now you have concrete Surprisal calculations and a concrete way of interpreting these in terms of ordinary coin tosses. Isn't that amazing? And finally, here is a summary of the Surprisal values that we've calculated. For Bessey sequences of order 8, the Surprisal is 6.13 bits. For Quasi-Bessey sequences of order 16, it's 13.65 bits. And for Bessey sequences of order 32, it's 29.16 bits. I want to point out that the Surprisal value associated with being struck by lightning is about 18 bits. So what that would mean then is that the Surprisal associated with a Bessey sequence of order 32 performance is not far off of the Surprisal value associated with being struck by lightning twice during your life. So that is a huge Surprisal value, and consequently a tiny probability that that event could happen by chance alone. And the other interpretation that we gave that's quite fun is the 6 bits for Bessey sequences of order 8 is the level of surprise associated with scoring 100% on a true-false quiz for which you did not study and you randomly guessed answers. For Quasi-Bessey sequences of order 16, it's similar to a 14 true-false question quiz in which you nail it even though you randomly guessed on all of the answers. You had no clue. And the Surprisal value of 29 bits for Bessey sequences of order 32 is the same level of surprise one would experience in acing a 29-question true-false quiz without having studied at all, and you just randomly guessed each and every one of the answers. But nonetheless, you got all of them correct. So that would be another interpretation for 29 bits of Surprisal. So thank you for watching, and in the next video we will take a look at additional examples of Surprisal that arise for performances that have or will be shared on the Hidden Structures channel. So thank you again for watching.